Linear equations. So we're going to build on the skill that we started doing when we were just solving two-step equations. So here's what we're going to do. With these equations, you're going to simplify as much as possible before you start using your inverse operations. And what I mean when I say simplify is you're going to use the distributive property sometimes, and you're going to combine like terms sometimes. And you're going to make sure that there's nothing else that you can simplify on either side before you start using inverse operations to get the x alone. When you have variables on both sides, like we have here, I keep writing over the words, hold on. When you have variables on both sides, most of the time, okay, you heard me, I said most of the time, you want to choose the smaller one and do the opposite or inverse operation. Most of the time. We're going to see one where that's not the case, and I'll explain why when we get to it. But most of the time when you have variables on both sides, choose the smaller one. The reason why I recommend you choose the smaller one and do the inverse is because there'll be less negatives, right? That's always a good path to choose, right? Less negative numbers. Okay, so let's try one. So we're going to simplify this. Always look to combine like terms first. So I've got like terms here. They're both constants, and so are these. So I'm going to combine those first. So 2, I'm going to leave that. I'm going to leave this. Positive 8, positive 4, they combine to give me a positive 12. 200 minus 20 is 180. All right, now, just like we learned when we did solving two-step and multi-step equations before, I could divide both sides by 2 right now if I want. Or I could distribute the 2 in. So I'm going to show you this method where I distribute the 2 in. So 2 times 3y would be 6y, and 2 times 12 would be 24. Okay. Now we're going to solve this basic two-step equation. First, I would subtract 24 from both sides. That leaves me with 6y equals, what does that equal? 156, right? And then the last step would be to divide by 6 on both sides. And I end up with y equals, I'm going to do this on the calculator because I don't actually know what that is. 156 divided by 6 is 26. Okay, so we combined like terms, we used the distributive property, and then we started using inverse operations to solve. This one is a little different because we have variables on both sides. So let's combine like terms first. I can combine the 5 and the positive 11. So I would have a equals 16 plus 3a. Now, you know that at the beginning I said when you have variables on both sides, look for the smaller one and do the opposite. In this case, that's going to create more work. Because if I look at the smaller one, right, I've got an a and I've got a 3a. If I look at the smaller one, that would be my a term. If I do the opposite to that term, then that's going to give me a 0 on the left side of the equal sign, and all my terms are going to be over on the same side. That's not helpful. In solving equations, I want to try to get the variable alone, right? I don't want everything on the same side. So, since I've already got an a term on the left, it makes sense for this one to do the opposite of this term. Now the reason why is because remember, I'm trying to get the variable alone. So now when I have 1a minus 3a, That gives me negative 2a, right? Because that's the same as positive 1 plus negative 3, which is negative 2. And now I have my variable term on one side, my number term on the other side. That's what I was trying to do, right? Because I want to get the variable alone. So the last step would be to divide by negative 2, divide by negative 2. Any number divided by itself is 1. So I get a equals negative 8. Okay, that would be my final answer. With all of these equations, you can always plug back in and check. If I put a negative 8 in here and I put a negative 8 in here, then the left and right side will be equal. Let's do another one. Always combine like terms, right? So I'm going to combine these two, and I'm going to write it over here, move it over a little bit. So I have 5x minus 2 equals negative 7 minus 9 is the same thing as negative 7 plus negative 9. When I add those two together, I get negative 16. Now I've got x terms on both sides. I've also got constant terms on both sides. So this is where I would look to see which of my x terms is smaller and do the inverse operation for that one. So 3x is smaller. So the inverse of adding 3x would be to subtract 3x. And I do that from both sides, but only to the like terms. Remember, I can only add or subtract like terms. So those cancel. 5x minus 3x is 2x. Bring down everything else. Now I've got a regular two-step equation, just like the ones that we did when we first started solving equations, when we talked about wrapping and unwrapping, right? So the last thing to be done here with order of operations is subtraction, so it's the first thing that has to be undone. I bring down the 2x. Negative 16 plus 2 is negative 14. The last step is to divide by 2, and I get that x is equal to negative 7. Now, this question says, how many solutions does the equation have? And you might be thinking, that's strange. Usually we just solve it, right? This equation has one solution. It is negative 7. Sometimes, instead of getting x equaling a number, you're going to end up with something that is like 5 equals 5, let's say. If you end up with all your variable terms canceling out, like they just all cancel and undo each other, right? They're all just gone. And you're left with something that's true, right? This is a true statement. 5 does equal 5. Then this equation has infinite solutions, or we can just say many solutions. If your variables cancel out and you get something that is false, like 2 equals 5, right? It's a false statement, then that equation has no solution. All right, so just to recap, if you have one answer, that means it has one solution. If you get a true statement with no variable, that means there's many solutions. If you get something false, that means there's no solution. And sometimes it's not just the numbers. Sometimes you'll have something like x equals x. That's okay. That's still true, and that would still mean that there are many solutions, infinitely many solutions to that equation. All right, one more to go. I saved the best for last. So on this one, we've got a lot of simplifying to do. First thing I'm going to do is distribute this 2. So I've got 6x plus 2 times x is 2x. 2 times negative 5, or minus 5, is negative 10. Then on the other side, I'm just going to copy. All right. Now I have like terms that I can combine, right? I can combine these two, and I can combine these two. So that's what I'm going to do next. 6x plus 2x is 8x. And then I just brought down the minus 10. And then 4x plus 5x is 9x. Now I'm going to stick with that advice that I told you in the beginning, which is go with the smaller one, right? Do the inverse. The smaller of my x terms is 8x. So if I do the inverse, that would be subtracting it. Because right now, it's that you can't see it, but it's a positive 8x, right? It's being added to the left side. So the inverse would be to subtract it from both sides. So now I get negative 10. 9x minus 8x is just 1x. And I bring down the minus 3. There's one more step to get the x alone, and that would be to do the inverse of subtracting 3, which is add 3. Negative 10 plus 3 is negative 7 equals x. All right, so that would be my solution. So there's a lot going on in this problem. First, I had to distribute. Then I had to combine like terms. Then I had to look for my smaller x term and either add or subtract it. In this case, I subtracted from both sides. Then I finished solving my equation. All right, so just lots and lots of steps, but still the same method of solving.